From the VC perspective, we hear a lot of different entrepreneur pitches talking about being in the cloud, and I think that overall topic has been somewhat bastardized. The overall word of cloud is being bastardized, but there actually really are interesting startups that are coming up with viable business models and monetizing on those platforms. And so, without further ado, I want to turn it over to Peter. Peter has a really interesting background. I think you've been involved with various types of MIT forums in the past.
That's correct.
Peter is also an MIT alumnus and has a really interesting background from a technology perspective as a journalist and now as director of platform research at Salesforce, who's a real innovator in this space.
I'm not just going to be talking about the Salesforce.com vision of the cloud, because what's much more important is to understand that the cloud has now become a very diverse marketplace with many people providing fundamentally different services. And it's easy to get overwhelmed by the list of the technologies that go into that. You will hear people say, oh, cloud computing is virtualization. Oh, cloud computing is doing this on the internet. And I hope I'm going to debunk that and get you to see a very small list of very fundamental economic benefits that the cloud label should entail. If someone's going to say that what they're doing is cloud as opposed to just outsourcing or as opposed to time sharing or whatever. And I want to start with a story. Late last year, there was a real oh heck moment at an agency whose name we all know, because they were absolutely, positively required to undertake a major project during the year 2010. It's in the Constitution that they absolutely have to do this every 10 years. And they need to spin up a rather large temporary labor force to go knock on doors and get information from people who didn't mail in the simple form. And the database wasn't going to be ready. And this is sort of like, a Y2K, only it comes every 10 years. The deadline was simply not flexible, and they had to do something. And so they went not to plan B, because they didn't really have a plan B. They went to plan H. And 6 weeks later, they had built the database. And 6 weeks after that, they had the application up and running to manage a temporary labor force of 170,000 people working for 2,200 partner companies all over the country. And I mean all over the country. And they will use this app for probably about 18 months. And then they will shut it down. And it won't cost them anything after that. And if you remember nothing else about this label of the cloud, it should mean the ability to respond on a ridiculously short time scale to a ridiculously volatile workload, to get something done, and when you're done doing it, to stop paying for it. And if you can't achieve those goals, then I'm sorry, I don't think you've gotten the point of what the label of the cloud should represent, because it's fundamentally about that ability to respond and to align cost with value, to do things and scale them up if they work, and kill them without mercy and without continuing cost if they don't. And with that said, let's get into the details. Now, I said I wanted to really stress the idea that the cloud is a multi-product, multi-vendor marketplace. There are a lot of things you can do that I will, without argument, qualify as cloud computing. Amazon will spin you up virtual servers, what they call VMIs, virtual machine images. Every one of them behaves just like a Xeon white box server, and you fill it with your desired stack of an operating system and middleware and so on. And this is really cool because you can scale at an amazing rate. There's a classic case, a little company called Animoto that does music videos to order. They did a viral marketing campaign on Facebook, and over a period of 72 hours, their demand went from 50 servers to 3,500. They would later say that with literally all the money in the world, you could not purchase, install, configure, and activate more than 3,000 servers over a long weekend. Just not doable. But because they were using virtual servers, they could simply say, we need more. Remember the big brawl scene in, I think it was the third Matrix movie, and Agent Smith keeps saying, more. Well, same thing, only this is with servers instead of people in sunglasses. Now, there are issues with this model. It is a utility model, except that it's sort of like waking up in the morning and calling the water company and saying, I'm going to be taking my shower in 5 minutes, spin up another pump. It's better than having to buy the pump and install and operate the pump, but you need to do explicit capacity management in this model. And so you do create some new complexity to go with those new economies. So make sure you, keep that whole picture in mind. Over at the other end of the spectrum is what we had the luxury of doing from a clean sheet of paper about 12 years ago. We said we're not going to expose anything that looks like virtual servers. We're just going to expose APIs. Our model is turn the tap open more and get more water. You don't call us and say, I need more capacity. You just get it. And so all of our focus is on the APIs that handle things like content management and workflows and things. I'll go into that in a little more detail. But the point is, all of these things I'm going to maintain have distinguishing characteristics that make them cloud computing as opposed to merely outsourcing. I'll elaborate on that in a moment. Now, the other big player, of course, that's just come in is Microsoft with Windows Azure. So the question is, well, where do they fit? I think they fit more over here than over here because it's still essentially an attempt to offer something that .NET developers will recognize. It uses the same tools, many of the same languages and facilities like SQL Server, in a model that they're saying is going to be more scalable. It's obviously still a nascent offering. They just brought out SharePoint 2010, which has a big online component, which does not run on Azure because Azure is still not even in full production release. So obviously something big is going to be happening in that space, and I mean literally big. You can see these data centers from space. The one that's under the approach path going into O'Hare is the principal consumer of the output of a nuclear power plant. I mean, they're investing immense amounts of capital in the capacity for this, and they have to, because their model is lots and lots and lots of copies of the Windows operating system. They're running in a virtual environment, but they have to do an awful lot of duplicates of the same code because that's the model that they're trying to scale. You will notice that even as they talk about the familiarity of things like SQL Azure, which is the SQL Server database model running in the Azure environment, they are also talking about new stuff, a new Azure storage model, which bears an amazing resemblance to what Amazon and Google are already doing. So you can tell they're trying to boil the frog slowly and move their existing ecosystem into a world where you don't own a resource unless you're actually using the resource, which really changes the way you write your applications. You don't have the registry as a scratch pad. You don't have lots of things that you always had in the PC model, where when you turned it off, things didn't go away. This is kind of like when you turn off a PC, somebody else borrows it for a while. It's a more stateless kind of model. All right, if things this different can all be cloudy, then is Larry Ellison right and the label of cloud means absolutely nothing? There's probably some evidence that Larry is wrong because his own people begin all of their vendor, trade show presentations now by essentially disavowing Crazy Larry in the attic and saying, no, really, we are in the cloud. Larry's very entertaining, but. So what is the cloud? There's a whimsical little rule among programmers. It's in the New Hacker's Dictionary called the 0-1 infinity rule, which is that in any properly designed system, you never see any other number. There's 0 of something because any of it would be bad, or there's exactly 1 of something because you don't want inconsistency or redundancy, or there's an unlimited number of something because if there's no good reason for it to be 0 or 1, there's no good reason for any other arbitrary number at all. There's no reason why you should be limited. And I thought this is an interesting set of numbers to apply to the cloud because 0 is your goal for on-premise infrastructure. Almost nobody really wants to own a server. Almost nobody. Okay, we, Amazon, Google, Microsoft, there's a small number of people whose business is running big server farms. Most companies don't really want to do it. Acquisition cost should be near 0. Adoption cost should be near 0. We're approaching these goals asymptotically. And you can see it in consumer hardware because 3 years ago, people bought great big honking 17-inch laptops. Some of these things had liquid cooling, okay? The only growth segment in PCs for the last 2 years has been netbook class machines, which are basically smile on a Cheshire cat. They're a screen, a keyboard, a Wi-Fi transceiver, and enough battery to make the thing work. And people are saying, why do I want to carry this around? Intel used to put lots of money into VC investments in bandwidth and processor-sucking applications like games and video editing. And that was how you sold people on the next round of CPUs, by making them think they really wanted to produce a movie in their home. And then they would buy a $500 processor wrapped up in a $3,000 PC. And now they're saying, wait a minute, this is a flip. You know, this is a flip cam. I push the button, I get the video, I stick it into the USB jack, and it's on YouTube 5 minutes later. This is what people are saying now. Why do I want to carry around all those resources? Why do I want to do all that work when Animoto will spare me from a half day of working with iMovie and produce that music video for my niece for her wedding or whatever? So that's the 0. What's the 1? 1 is that when you plug in, it always works. There's one thing and it's always working. Now that might seem like a very low bar to jump over, but if you look at the way that IT's been done for a long time, even if you bought all your stuff from just one company, different pieces were on different release cycles. The client piece, the tools piece, the server piece, they all come out at different times, and everything works quite right. And when something new comes out, you do a lot of backward movement to do regression testing and things, and a lot of stuff gets broken all the time. And in a cloud app, that should not be the case. When you log in today, it should work just as well as it worked yesterday, ideally better. You should not have the burden of installing or testing an upgrade. You should not be required to buy new hardware to run the upgrade. You should not need to install additional hundreds of terabytes of storage because the ERP vendor moved to Unicode for the databases, to cite an actual example from fall of '08. And that's the 1. Now, given the 0 and the 1, and a lot of people get this right away. They say, okay, yeah, consumer web apps do this. The infinity surprises them. The infinity is not just scalability. We've talked about scalability. What people are very surprised to discover is that you can have this and still have this. You can still have the ability to integrate the services with other resources, with other services, and with stuff that you own and operate yourself. You can still have customizability and programmability, even though the code base is being shared. And that sounds like a contradiction. And I'm going to, I hope, make clear how it is possible to do that, because what that means for the entrepreneur, what that means for the startup and for the enterprise, is that you can have the advantages of all the economies while still having competitive advantage and proprietary value-creating business processes. So, here you are, you're a developer, and you're saying, how do I get me some of this cloud stuff? There's lots of different ways to do it. Since some of the models are essentially just, here's a virtual box populated with any code you want, well, the logical thing to do if you're a startup is to say, hey, I'm going to package my software in such a way that it just goes right into the cloud. You don't have to do any work at all. I'm going to, instead of having it designed to go on a CD and pop into a slot and install itself on a Windows machine, I'm going to package it so it installs itself in an Amazon virtual machine. This is what Alfresco did. They have an open sourced content management application which they sell to people who then customize it to add value for specific industries or to build a proprietary system for a particular company. And what they've done is package it as an Amazon Elastic Compute Cloud, EC2, an EC2 ready stack, and it just drops right in. And there's a developer kit, and their goal is to help you develop, deploy, and monetize a cloud content application. They've taken care of everything that has to do with making it work in the cloud. All you have to worry about now is, what value do I add? Maybe I'm going to put in specific content because that's the expertise I'm bringing to the marketplace. Maybe I'm going to put in customized processes to meet with the needs of someone who's doing clinical trials, or maybe I'm going to do something that customizes it for law office practice, whatever. The only thing I need to do is stuff that adds value to that foundation. Another way to do this is to say, let's look at things that the cloud doesn't quite do yet. For example, when Azure was first rolled out, it didn't support the very popular web scripting language PHP. And so an outfit called Real Dolman worked with Microsoft to build a layer that fit in between PHP stuff and Azure stuff to make it look like it was running PHP. And so this is another way that someone can get paid for what they know. If you were the world's leading expert on PHP, you probably had an opportunity to package that expertise in a form that made PHP apps work really, really well on the Azure platform early on. So that's another way that you can take what you know, take your intellectual capital, and turn it into an opportunity for advantage in the cloud. So what are the value propositions for the developer? Well, there's the old code and new clouds. you can look for a way to take code that people already know how to write, Java code, .NET code, whatever, and deploy that into a scalable environment. So if you know how to do Linux, Apache, MySQL, Python, Perl, PHP, open source stuff, you can run that in Amazon Virtual Servers very readily. And I believe you're going to hear from Aprenda tonight. Is it here now? Yeah, I'm sorry. You're right there. You're going to be talking about how your whole stock and trade is, here's an environment which your .NET app becomes a cloud app, right? Do I have that? Yeah. That's the napkin version of the mission statement, right? Okay. So you're going to hear about that in more detail. Or you can move to the other side of the chart and look for what we do, highly leveraged code. We have our own programming language. It's a Java family language. Looks so much like Java that some people think it's a dialect of Java, but we built it from the bottom up so it would guarantee database integrity and a few other things. And it's governed by the environment. And if you build your app with that language, it runs in our environment and gets some nice guarantees as a result. That's our model. You don't need to make a mutually exclusive choice between these two models. That's incredibly important to understand. If you've got stuff that's already been written, and works great in Java or .NET or whatever, or you want to preserve maximum freedom to use new code in future environments, you think it's going to last for a long time and maybe even last longer than we or Microsoft do, fine. Go ahead and write it in something like Java and run that in something like Amazon. People like Boomi and Informatica will help you tie these things together, and you will be able to say, let's see, I'm going to buy my storage and my bulk scientific and high-performance computing capacity over here in Amazon space, and I'm going to buy some analytic graphics that I really like from Google and wrap a collaboration environment built on Google Docs around my app. Use Force.com so that I can deliver a version of this very quickly to handhelds and deliver it into internationalized environments, and then build this thing in such a way that you can drop it into your Facebook page and get a viral community going around your protein folding calculations. Work with me. It could happen. It could happen. And critically, it's not just about the one big cloud with all of these variegated services available in it. It's also about the fact that you can tie this together with your SAP and Oracle resources. You can go out and mine the dark matter of your universe that's out there in your Word documents and your PowerPoint files. You can use the services of people like the Informaticas and Boomis of the world to tie this stuff together. And if you know that you're going to be working with a composite architecture for the indefinite future, fine. Go ahead and write some custom code to tie these things together. Custom code's not a bad thing. It should just be used only when you really need it. I have seen situations in which a relatively simple database query was replaced by 10 lines of Java code at a factor of 100 speed up as a result, because that one query was being run again and again and again and again and again. It was just dumb to parse that puppy as a SQL expression every single time. They realized, you know what? We should just hard code that thing. 100 times speed up. So by all means, use code when it's appropriate. Now, here's the thing that, as I said, really surprises people. You can have this enormous shared code base. We've got 80,000 organizations, 2 million individuals using that code base, and we can do upgrades 3 times a year. And everything that's special to you, your user interface, your data, all that's just in one little pocket, along with the other 80,000 pockets of metadata that make each customer organization's view of that shared code quite unique, quite differentiated. Here's the thing that startles the heck out of people, is that custom logic can also be represented as a variety of metadata with acceptable performance. This is kind of like the shock when people realized, oh my gosh, I don't need to write everything in machine code. I can write stuff as a .NET assembly and still get acceptable performance. You get to move up that abstraction ladder, and you get tremendous results from that. So what can you do as a result? I have seen someone who never had touched our system before, ever, under purely verbal instruction. Someone saying, okay, now you see that menu there? Click on that. Yeah, you see that option there? Click on that. Okay, check those 3 boxes. That kind of instruction. Build an application that initiated an approval process, escalated the request for approval based on an Active Directory lookup, sent the request out by email, parsed the email reply looking for the word approved in the reply, and if it saw it, moved the process onto its next stage. Pretty nice stuff. Constructed by someone who did not know how to write code, who had never seen this environment before, in 20 minutes. That's the kind of leverage I'm talking about. And so things like building the content management capability, building workflow rules into the system, building query optimization in there so that you don't do database query optimization anymore. You don't do index structure maintenance anymore. All of these things now become platform properties. Some of you may have heard that in the last couple of weeks we've announced our largest acquisition to date. We bought Jigsaw, which is a crowdsourced data quality maintenance community, which will still have an open API, will still be an accessible resource for other systems, but it's going to be very highly integrated into our system so that if you have a system that works with data that's volatile, like where people work and what they do, data quality maintenance will now essentially be a built-in property of your applications. I've talked about Java. As of later this year, we will be in full preview on a capability we've jointly developed with the M-Force that will let you simply run standard Java written with the Spring framework in our multi-tenant environment without any changes. I don't have enough time really to go into the depths of the developer offering, and I don't think this is really a developer-heavy crowd, so I'm going to go ahead and skip past this one. This is also pretty much developer-oriented, the visual tools for process definition. The whole emphasis I want to bring here is that this provably increases development productivity. We have 4 actually completely separate studies. I've only summarized 3 of them here that were done by completely separate teams with completely different populations of developers. All of them agree within 1 decimal place that you'll get a 5-fold acceleration of the development effort because you're not writing as much code as you had to write before, you're not testing as many things as you had to test before, things just fit together better. I'm particularly proud of this one because Gallerith's only product is software cost estimation tools. That's what they do for a living. And so when BAE PLC, the systems integrator in the UK, wanted to pitch the FAA on writing applications on a cloud platform, the FAA said, well, we use the Gallerith tools to run those projects. Are those calibrated for this like they are for .NET or Java? And BAE said, well, no. And the FAA said, well, darn, that's just a real shame, isn't it? BAE got the message and spent 20 months and their own money to get Gallerith to go out and do the field research to calibrate their cost estimation tools. So now you check the Force.com box instead of the Java or .NET box, and they came up with this result that you would cut your development effort by 80% by using these facilities. So what happens? What happens is that you got a company like Animators at Law. They do litigation graphics. I didn't know that was an industry until I ran across this case study. But all those great things that expert witnesses do, there are people who, they're professionals producing those great demos for the jury. And they thought, okay, this is a nice business, but what if we tied it together through LinkedIn with LinkedIn's knowledge of the legal community and who works with who on what cases, and Google News feeds on relevant stories involving things like big class action suits, pull the whole thing together, turn it into a software as a service offering called Law Prospector, bring it to market under their name, and all of a sudden now, they're a software as a service provider without owning a single server, because the whole thing is running in our environment, in LinkedIn's environment, and Google's environment, and what they've contributed is their own distinctive expertise and their branding. And that's all they've had to do. Not a lot of capital on the line, not even any added development staff. Tremendous opportunity to monetize intellectual capital that they already had, but couldn't have really been able to get over the activation barrier to bring to market as a software as a service offering if they'd had to build their own provision infrastructure to do that. This and the census story are the 2 examples I really want you to remember. You can get stuff done and you can make tons of money that you would never have been able to afford to pursue before because of the enormous barrier to entry, and now the barrier to entry is pretty much non-existent. Now here's the other thing that we're doing this year that's really exciting. Lots of people want what Facebook or Twitter or other social media can bring to your company, but they are rightfully worried. Anyone see the New York Times story with the graph of all the Facebook privacy settings? 1,300 different possible choices you can make, buried in 20 or 30 different places in the Facebook architecture. They want to have intrinsic security. If you start with a system that's designed to share by default and try to configure it for security, it's easy to screw up. We thought, what if we started with the other approach? What if we started with our existing data model with extremely precise and granular management of privilege and added real-time feeds and other social networking mechanisms to that data and trust model? That's what we've done in something called Chatter, which is currently in a broad private beta and will be in general availability this year. We are using it internally. Our email volume is down by more than 40% because people now are getting stuff done in an environment that looks a lot like Facebook, but with the intrinsic security that if I don't have visibility of the data, then I don't have visibility of the update to the data. And I don't just follow people, I follow an account, I follow a case, I follow a spreadsheet. And if it changes, I get a message saying this thing has just changed. And it shifts the whole environment into one of real-time, proactive awareness of what the heck is happening so that I can solve problems while they're tiny. It's incredibly exciting. Now here's the other thing that I've mentioned is the announcement that we made at the end of last month with VMware. We've always understood that it was a fundamental issue for developers if we said, look, we've got a great programming language, but it's not the one you already know. The syntax looks just like Java, but no, in fact, you can't use your existing Java libraries. We knew we had to solve that problem, and so we've announced with VMware a major joint initiative to take the Spring framework combined with standard Java and the vCloud, which is VMware's big contribution. So now simply by dragging the icon of your application to the VMforce icon, instead of dragging it to the icon representing the server in your basement, you have just deployed that Java app into a fully scalable, highly available, highly secured enterprise cloud environment. That's straightforward. We've already demoed this. It already works. Now we just have to get it up to full capacity before we turn on the broad developer preview later this year. And so Force.com developers can use their existing Java code. That's good. Java developers can use all this other stuff that I've just described that will make the rest of their application 5 times as quick to build. And CIOs can say, oh, good. It's running standard stuff. I'm not betting the farm on this new proprietary stuff. So here's the new architecture of what we're talking about. The cloud infrastructure that just runs, the VMforce layer that will let you use existing resources if you have them and want them, the Force.com layer that lets you do stuff like analytics and content management, and then this new Chatter framework that lets you immediately add social network capability to your existing stuff. How important is this to the entrepreneur? If at any time during the 3 years that we've been offering the Force.com platform, you had brought a product to market on that platform, as of later this year, your product will now have social networking capability built into it, and you won't have to write another line of code to make that happen. It will simply manifest itself as a new feature of your application. Your apps become more valuable every time something happens down in that big red box that makes the shared code base more powerful. So that's what I wanted to share with you. This is where we see venture capitalists, entrepreneurs, and enterprise developers looking for the opportunity to work with a trusted service provider instead of building their own infrastructure from scratch, have low cost of entry, which means low cost of experimentation, faster time to market, which means first mover advantage means something again, and a high level of assured interoperability. And I'm really, really happy with the 2 people following me on the program tonight because they are going to speak directly to these same strengths. You're not just going to be hearing it from me, that you can work with trusted providers who will give you high uptime and a rigorous record of reliability, which is crucial because people feel like they're giving up control when they adopt this model, and you can get high levels of interoperability with other services. That's also crucial because no one wants to rip and replace, no one wants to duplicate. And I think I should shut up and let them talk. Thank you.